Mars, the red planet, has long captured our imagination. But despite our technological advancements, the dream of humans setting foot on Mars may remain just that, a dream. In this video, we'll explore the daunting challenges that make this mission nearly impossible. The distance between Earth and Mars is staggering. Depending on their orbits, the distance varies from 34 million miles to 250 million miles. This immense distance presents several significant challenges for space travel. A one-way trip to Mars could take anywhere from 6 to 9 months, depending on the alignment of the planets. During this time, astronauts would be exposed to prolonged periods of space radiation. Unlike Earth, which is protected by its magnetic field, space offers no such shield. This exposure increases the risk of cancer, damage to the nervous system, and other health issues. Microgravity also poses a severe threat to human health. In a microgravity environment, muscles and bones weaken, and fluid distribution in the body changes. Astronauts on the International Space Station exercise rigorously to combat these effects. But a trip to Mars would require even more extensive measures. Bone density loss, muscle atrophy, and cardiovascular deconditioning are all significant concerns. Living in a spacecraft for such an extended period also presents challenges. Life support systems must provide reliable air, water, and food recycling. Any failure in these systems could be catastrophic. The confined space and lack of natural light could lead to psychological stress and fatigue, compounding the physical challenges. Communication with Earth would also be a challenge. Depending on the distance, there can be a delay of up to 22 minutes for a signal to travel one way. This delay makes real-time communication impossible, complicating mission control and support. Once the astronauts arrive on Mars, they would need to quickly set up habitats to protect themselves from the harsh environment. The initial landing site selection is critical, as it must provide resources like water, ice, and shelter from radiation. Any delay or error in setting up these habitats could be life-threatening. Emergency scenarios add another layer of complexity. In the event of a medical emergency or critical system failure, immediate evacuation back to Earth would not be possible. Contingency plans would need to be in place to handle such emergencies, but the distance and isolation significantly increase the risk. Mars is a world of extreme and unforgiving conditions. The planet's average surface temperature is around -80 degrees Fahrenheit, but it can vary greatly, from a chilling -195 degrees at the poles during winter to a relatively balmy 70 degrees at the equator during midday. These extreme temperature variations pose significant challenges for human survival and the integrity of equipment. Any habitats or machinery would need to be highly insulated and capable of withstanding these temperature swings. Mars is also known for its massive dust storms, which can cover the entire planet and last for weeks or even months. These storms can significantly reduce visibility, block sunlight, and damage solar panels, cutting off a vital energy source. Dust infiltration can also clog machinery and habitats, leading to maintenance nightmares. The thin Martian atmosphere, composed mostly of carbon dioxide, is less than 1% the density of Earth's atmosphere. This offers almost no protection from harmful solar radiation and cosmic rays. Prolonged exposure to these high levels of radiation can increase the risk of cancer and cause acute radiation sickness. Habitats would need to be heavily shielded, which adds to the complexity and cost of building them. Water is essential for human survival, and on Mars, it exists primarily as ice. There are no liquid water sources on the surface due to the low atmospheric pressure, which is about 0.6% of Earth's pressure at sea level. Extracting and purifying water from ice deposits would require advanced technology and significant energy resources. Radiation protection is a major concern. Potential solutions include building habitats underground or covering them with Martian soil to shield against radiation. These methods, while effective, complicate construction and habitat design. Mars has about 38% of Earth's gravity, which can have long-term health effects on the human body. Prolonged exposure to low gravity can lead to muscle atrophy, bone density loss, and other health issues. Exercise regimens and other countermeasures would be essential to maintain astronauts' health. Creating a sustainable human presence on Mars isn't just a matter of getting there. It requires advanced technology and extensive planning to overcome numerous logistical hurdles. Mars habitats must be designed to protect inhabitants from the harsh Martian environment. These habitats need to provide air, water, food, and temperature control. Building these structures on Mars presents enormous engineering challenges. They must be robust enough to withstand extreme temperatures and radiation while being efficient in using resources. Life support systems are crucial for survival. They must recycle air and water, providing a continuous supply of breathable air and drinkable water. The systems need to be incredibly reliable, as a failure could be catastrophic. Innovations in closed-loop life support systems, which recycle waste products back into usable resources, are essential. Food production is another major challenge. Transporting enough food from Earth for long-term missions is impractical. Instead, astronauts would need to grow their own food using methods like hydroponics and aeroponics. These systems allow plants to grow without soil, using nutrient-rich solutions and mist, but require precise control of the environment and resources. Transporting equipment and supplies to Mars requires meticulous planning. Current spacecraft have limited cargo capacity, so multiple missions would be needed to deliver all necessary materials. This includes not only initial supplies, but also regular shipments of spare parts, food, and other essentials. Coordinating these missions across millions of miles of space is a logistical nightmare. While the dream of reaching Mars continues to inspire, the reality is fraught with challenges. However, space exploration can still yield valuable scientific knowledge and technological advancements. Perhaps one day we may overcome these barriers. Until then, Mars remains a distant horizon. What do you think about the possibility of humans colonizing Mars? Let us know in the comments below. Don't forget to like, subscribe, and click the bell icon for more fascinating content. See you next time on Topic Twister.